Hello, I am Animangshu Ghatak. I am a professor at the Department of Chemical Engineering at the Indian Institute of Technology, Kanpur, India. And today I will like to tell you about our novel reprintable paper. More than 50% of all papers printed in offices, schools, colleges and universities and homes are used only once before being disposed of to the garbage box. Environmental cost of such one-time use of paper is rather huge. Studies suggest that 25 lakh trees are cut down each day for making paper, which is equivalent to 5,000 hectares of forest. For making one A4 size paper, it requires 5 liters of fresh water and it generates roughly 4.17 grams of carbon dioxide. Current global usage of A4 sheets is 25 trillion per year, making of which is expected to wipe out 60 million hectares of forest, equivalent to the area of the whole of France. Many a times papers are left to rot. Rotting papers emit methane gas, which is 25 times more harmful than carbon dioxide in terms of greenhouse effects. Even recycling of used papers involves significant costs in terms of energy, water and associated pollution of the environment. Electronic gadgets have been proposed to be used as a substitute for paper, but these gadgets become obsolete very rapidly, thereby causing ever-increasing volume of e-wastes. The process of recycling these wastes is not yet fully established. To put it in perspective, 54 million ton per annum e-waste are generated globally, 85% of which ends up in landfills and incinerators, where it releases extremely harmful toxins of different kind. In essence, a viable, eco-friendly and effective alternative to paper simply does not exist. It is to address this problem that we have made a novel, rewritable, reprintable paper which allows writing by most conventional pens, ballpoint and sketch pen, and printing by laser jet printers multiple times. In essence, we have been inspired by the inherent ability of many wall climbing animals like geckos and insects. They have adhesive pad under their feet which allows them to stick to a variety of surfaces, rough and smooth, clean and dirty. Their adhesion becomes strong enough that these animals can dart vertically upside down while also carrying a payload. Yet, when dusts and particles adhere to their feet, they can easily shear them off to keep their feet clean. Thus, they meet exceptionally well the conflicting demand of strong adhesion yet easy release. The key to this ability is hierarchical hair-like structures that constitute the adhesive surface under their feet. After studying the physics of adhesion by such naturally occurring patterned surfaces, we have prepared hierarchical random topographical features of dimensions ranging from tens of nanometers to hundreds of microns by casting silicon films on a suitable substrate. A flexible substrate like conventional paper is used as the backing layer on which this film remains strongly bonded. On the surface of this film, ink particles of wide-ranging sizes and surface chemical characteristics adhere via intermolecular interactions. The ink particles bond with the surface strong enough, they do not get dislodged because of gentle wiping with finger or an object. However, unlike conventional papers in which particles get mechanically trapped inside the porous network of the cellulose fibers, here the ink particles remain accessible for cleaning. Simple scrubbing with a rough surface soaked with a suitable liquid removes the particles and completely cleans the paper for reprinting. Experiments show that the paper remains usable over 50 cycles of cleaning and reprinting over a number of years. Being a one-step process, our method allows scaling up of manufacturing of the reusable paper. Furthermore, unlike polymeric materials like high-density polyethylene, low-density polyethylene, polypropylene and several others, which are expected to remain on our earth for 300 years, silicon gets degraded within few years by the forces of nature and turns to sand. Thus, our reusable paper provides an economically viable, eco-friendly and benign solution that does not burden the environment with pollutants like many others. Our reprintable paper is expected to cut down drastically the cost of writing and printing and also have a lasting impact on the environment. More about our reprintable paper can be found in our publication titled Gecko inspired hierarchically rough surface used as a reprintable paper, published in the journal Chemical Engineering Journal Advances 2022.